Good evening and welcome to the Imperial Workbench. So this evening you'll see the workbench is in a state of deconstruction. I was hoping to move house last week, but there have been some problems, so that looks like it's delayed a little bit, but nevertheless the workbench was fully packed away. The whole workshop in fact is in boxes underneath where the camera is. And I thought it would be a great opportunity to give the lathe a good seeing to. So as you can see, it's broken down almost completely. All the pieces are in the box down here. One thing that I thought that while I was disassembling it, that I thought was worthy of investigation is the countershaft pulley. So this is the close-up view of the ML7. You can see I've removed the motor pulley, which is just here. And here we have the guards for the spindle belts and various grub screws and oiling caps and so on. And this is the countershaft spindle. So the pulley sits here, the motor sits behind and drives this large pulley wheel attached here. And in my mind, this feels like it should be a very freewheeling pulley. If I engage the cam, which engages the belt, then there is resistance there, and in my mind that resistance is from the gears here. But if I remove that, I think this should spin pretty freely. But actually, it's not that easy at all. I actually have to move it around myself. And I'm thinking the motor is losing a lot of efficiency and is consuming a lot of power just to rotate this, before it's even worrying about rotating the spindle itself. And I wonder how much I'm losing there. So after a few days, this is what we have. Here you can see the new Myford countershaft against the original. And now this isn't dirt, this is scored in. Especially over here. You can really tell. Here's the bushes. As you can see, they're very, very smooth. Got two new drive belts. I got a new thrust washer just on the off chance that it was a couple of quid, so why not? And these are washers, fiber washers, 1/8 inch BSP for the oilers, which I thought rather than getting new oilers, I'd just replace the washers. And this is the contents of the toolkit from a gentleman, Robert Tretherick, I think. Rita's Ears is his website, and basically it's the bits that you need to press out these bearings and then replace them. Because the challenge, of course, is they're an extremely tight fit, so you can't just hammer them out, and you definitely can't just hammer them in. So what we've got is a series of concentric pullers and pushers that we ratchet into this mechanism here and push out the bearings either way, and then push the new ones in. So I'm going to do that. Once that's done, we need to use a tapered reamer, which is in here, so an adjustable reamer, to ream out the bearings to an exact sliding fit for the countershaft here, because the bearings actually get compressed as they get pushed into the bushes. So the bushes get compressed as they get pushed into the bearings. So that needs to happen there. And then it's a case of reassembling the whole thing and making it ensure it still works. So I'll let you know how that goes. Good evening and welcome back to the workbench. As you can see, the ML7 is back together again after a full day's worth of hammering, malleting, swearing and so on. So it's in good condition. I'm really pleased. So right now I can rotate this countershaft with one finger, even though it's attached to the motor currently and it's basically hanging. There's a lot of tension on this. Whereas before I couldn't even rotate it around. So that process was to remove this cover, remove this cover first, then remove all the grub screws, remove this shaft here, so then this assembly can move out over here, and then press off this end cap, hammer off this pulley, and then use a mallet to gently tap out the middle pulley set here, and then the shaft comes free. And then the process for getting these bushes out is to use threaded rod with some pushers. So you put a cup on this side with a threaded rod through it, a pusher on this side, and then a nut, and just wind the nut, and the pusher just pushes the bronze bushes out, and just repeat the process to go back the other way. That was okay. I needed to use a tapered reamer, as you can see down here from the mess, which is in here, because the oilite bushes shrink as they get pressed into the lathe, and then so I had to size those perfectly to the counter shaft. I think the biggest challenge definitely was working around this Mazak casting, because it's not that tough. It can bend and it can flex, so you can't lever against it, you can't hammer it, and then conversely, trying to get the alignment of them both perfectly, even though I had the holes within a couple of thou of each other, and the bar is obviously ground steel, it just wasn't aligning properly, and so I had to open out this one just very, very slightly. You know, maybe 1 or 2 thou across that length, and this is just a three-dimensional casting with lots of curves that you can't really bend properly. But got that going, and I'm really quite pleased with it. If I put it back together again, turn it on, you can see there's a bit of hissing because I think the tension on that belt's a bit high, because I haven't done the retaining nut up down here on the motor properly yet. But I'm just really, really pleased. It's taken me ages to do this. It's taken a lot of patience, but we're there, and I'm just overjoyed. So thanks very much for coming on this journey with me. If you've got any questions about how I did it, or I can help in any way, please let me know.